Okay, it's interesting. It seems that leverage has an effect on the gravity of this. Let's say I put one there, one of these wee wedge shapes there, one there, stress the structure. Place one there, it does not stress the structure. And now it's stressed permanently. Break. Weird. But no. Yeah, place any more and that will stress it. Whereas I can get that one all the way out there using these shapes. What do you call it? Anti-prisms. Square-based anti-prism. So 1, 2, 3, 4 square-based anti-prisms and one square. I can get that much further than this one. Using only squares. It's 1, 2, 3, 4, 5, 6 cubes. Sorry, cubes. I'll get rattled out for that, man. And there's 4 anti-prisms, square-based anti-prisms and a cube within this one. And they both are not getting stressed out. Oops, I wanted to put a cube there. So either way, something stretches that out. Ah, don't worry, I'll get my materials back anyway when it falls in the void. Interesting to note though, that bridge had 36 materials in it. And this one has 10 plus whatever falls in the void. 36. That one had 46 materials in it. So the number of parts in it does not seem to have an effect. Oh, that's 5 now I can get with that base. 6. And why is it that one is taking stress and that one isn't? Well, I found coral wood is actually a lot better than jasper for taking strains. Right, let's see how that increases it. Hey, good dog, sit. 2 more. 3. Oh, no. Yeah, I know a piece didn't have no but yeah. 1, 2, 4, 5, 6, 7, 8 long. Okay, you can get 8 of these. It stretches all the way out there. Let's test that in the cubes just to make sure it's still the same results. 2, 4, 5. I'm sorry. So is it to be here? This comes out to. It'd be weird if it's a short range that works better. The anti-prisms that does with the cubes. 4, 5, 8. Is it? Yep. Nope, still comes out further. I can probably still stick a cube in the end of that. Nope. Oh, hold on. That's stressing it more to have a cube on it than it does to have one of these on it. No, it was stressing the same amount, but on the opposite side. Well, just try to see if there's anything sticking into this that'll actually work. Oh, we got something. So we can put a pyramid in the end there. We can put one of these in the end there. I'm not going to try one of them. Try an isosceles pyramid. Oh, pyramid, wedge, sorry. Isosceles wedge, as opposed to the equilateral triangle wedge. There. What's actually a prism, isn't it? But that's technically a prism too, it's just taller. Right. Let's see, what's this shape? Whatever it is nearly like it. So, that is as far as I can get it without stressing it. That base. It's quite some distance actually. Right, so that's awfully weird. Something that has more parts in it does less stress, damn it, on the foundation than the actual part of the piece really. That's got 6 faces in it, or 6 parts to it. This has 10. That stresses it less than that does. Is weird. But I did notice when I was doing it that. Let's see. So you guys forgot to control sometimes. 4, 5, 6. Next one should stress it. Yep. So that's 6. And we have my 4 faces in it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wow. Not my 4 faces. Anyway, try this. It is 6 pieces it gets. This is 10. It gets 4 pieces before it gets stressed. So that's 4 times 10 is 40, and that one would be 46. Whereas this one gets to 42 pieces and it's stressed. So I was wondering, do faces that connect count as faces? Like, so that's actually 10 pieces, but it's actually only 8 if you count. Discount the faces that are touching each other, so 8, 16, 24, 32. That another one takes up to 40. But this has only got 5 more faces onto it. It makes 37. No, it's not going to stressing it. And now it's not stressing it. Okay. So that makes you up to 37 faces. Only like 1, 2, 3. Well, this one's already at 36. Well, if you count, that's actually 4. It's 24. So it's weird. You only get 24 faces, or you get 36 faces. Listen, so not makes it anything to do with faces. You know what I mean, like, well, all those faces there. Because either you look at it, 24 faces and 37 faces, or you count the faces that are missing, that is 46 and 36. So the parts in it do not count towards the weight, obviously. But you've got to look at this way, the leverages take effect somehow. I showed you earlier, like you put a piece there, put one there and it stresses it. And somehow it's still stressed. Right. Weird stressing going on here. And now it does stress it. This is weird. What? It was stressed and I put one there and it's suddenly not stressed. I'm wondering if it's actually getting stressed or is it just bugging out and saying it's stressed when it's not. Right. There. Yeah, no stress this time. Maybe it was the cube on the end that wasn't stress. Or maybe putting the cube in the, take the cube off the end, because it update its values. Right. Oh, I was creaking that time. See, it's not creaking. Oh, creaking there. So it's the sound you get listening for, not the dumb I'm under stress lines that are not actually right. So yeah, leverage has an effect on it. How much an effect? Right. So that's the maximum distance we can get you. Yeah, cause that. Huh. Perfect starting bomb. Right, anyway. Well, just take that in. Even further out. You're going downhill when you get there though. But it'll be perfect for bridging, like, get you to the other side so you can start building from the other side to you. Then you delete that later and connect them up again. Weird. Try to work out what the weight values are. So these obviously weigh more because you can get less on, but they're longer so you can get further out. Okay, I'll be using them to bridge in future. And you can still get one of them in the end. So once you connect two sides, the weight is distributed between the two sides. So if you can get like close enough with the build bridging out, you can build from the other side and connect the two. But then it's also got to be that if the bridge is too long, you have to have a big connection each side. Anyway, I was observing the weird properties of weight as to the size of the object. Also the volume of the object does have an effect in weight because you get less parts, but it's not corresponding to its... Or is it? Because that... is that... Because although that's longer, you're missing bits there and there. There... See, like, if that's a perfect square, would that still be? It would go as far. Or is it because it's missing these bits here, it's able to extend further, but have the same way? That's actually quite a weird thought. Because it's think volume there rather than... But if you think about it, the volume should be exactly the same, because it's just... a cuboid that's been twisted. But does the game count it as the same volume?